Let's talk about November 18th, 2025. On that day, a huge chunk of the internet, well, it just vanished. This wasn't some big, flashy cyber attack. It wasn't a nation-state trying to cause chaos. No, it was something much quieter and, honestly, a lot more scary. So we're going to break down exactly how one company's internal mistake managed to break the web for millions of people.
And to really get a sense of the scale here, we're talking about 1/5 of the entire web. Yeah, 20%. 1 out of every 5 websites you might have tried to visit, gone. If you were online that day, you absolutely felt this. It was just a massive, massive outage. And this wasn't some, forgotten corner of the internet. We are talking about the services that pretty much run our lives. Your work calls on Zoom, your group chats on Discord, scrolling through X, listening to Spotify, even asking ChatGPT a question, all of it just went dark. So that's the million-dollar question, right? How can one single problem cause such a gigantic blackout? The answer, well, it tells us something really important, and frankly, a little uncomfortable, about how the internet is actually built today. To get the how, you really have to understand the who. And at the dead center of this whole mess is a company that most people have never heard of, but has become an absolute pillar of the digital world, Cloudflare. I mean, just look at this chart. It really shows you how dominant they are. Cloudflare isn't just a player in the space. For all intents and purposes, it's the player. Of all the websites in the world that use what's called a content delivery network, or CDN, to make things faster, almost 80% of them, they all rely on Cloudflare. They're like the invisible highway system for a huge amount of internet traffic.
So you can imagine what happens when that highway suddenly closes down. It's instant chaos. For the engineers at Cloudflare, that morning became this frantic, all-hands-on-deck race to figure out what on earth was going on and get it fixed before everything just ground to a complete stop. This timeline really shows you how fast it all went down. The problem starts spreading at 11:20 Universal Time. Less than 30 minutes later, they know they have a massive problem. But it still took them another 2.5 hours just to get the main services back up, and almost 6 hours before the whole thing was truly over. That's 6 hours where a giant piece of the internet was just broken.
And for regular people like you and me, all we saw was confusion. Websites wouldn't load, your apps wouldn't connect. You just kept getting these generic internal server error messages. From the outside, it honestly felt like the internet itself had just decided to call in sick for the day. Now, when you have a global outage like this, your first thought is always, okay, who's attacking us? But the truth was a lot closer to home. The bad guy wasn't some hacker trying to get in. It was a ghost that was already in their own machine. That's right, this entire global mess was triggered by a software bug. Just a tiny hidden flaw that was probably sitting there totally harmless for who knows how long. And it was woken up by a completely normal, everyday update that someone was making. And here's the chain reaction. It's pretty wild. It all started with an engineer making a simple change to a database. But that tiny change accidentally woke up this bug, which then spit out a bunch of duplicate data. This extra data bloated a configuration file, making it way bigger than it should have been. And when that huge file got pushed out to the network, the core software that handles all the traffic just choked on it and crashed. Everywhere. All at the same time. The official report called it a data integrity failure, but I just love their other phrase for it, a poisonous input. See, the file wasn't formatted wrong, so it sailed right past all the normal safety checks, but the actual content of the file was toxic to the next piece of software. And that's what makes these bugs so sneaky and so hard to catch before they cause a disaster. So, the big question is, how on earth can a small bug in a seemingly minor system cause the entire global network to just fall over? The answer is all about how these massive, modern systems are actually controlled. To get this, we have to talk about something called the control plane. The easiest way to think about it is like the air traffic control tower for the entire network. It doesn't fly the planes, that's the data, but it's the brain that tells all the planes where to go, what routes to take, and basically makes sure nothing crashes. So when that bug created that poisonous file, it effectively blew up the control tower. The ripple effect was instantaneous and devastating. First, the systems that direct traffic, they lost their maps. They had no idea where to send anything. Second, all that amazing global redundancy that Cloudflare has, it was useless because the exact same bad software was pushed everywhere at once. And maybe worst of all, the very tools the engineers used to see what's happening, they went blind. They were flying the plane and trying to fix the engine in total darkness. And this right here is the biggest lesson from the whole incident. You can build data centers all over the world, but if the software brain that runs all of them has one single point of failure, your entire distributed network can be taken down by one bad line of code.
So how do you even begin to fix a catastrophe like this? And more importantly, how do you make absolutely sure it can never, ever happen again? Well, the recovery was careful and methodical, and the changes they made afterward show a huge shift in their thinking. So the immediate fix was like an emergency room procedure. Step 1, you stop the bleeding, kill the system that's making the bad file. Step 2, you administer the antidote, manually push a clean, healthy configuration file into the network. And step 3, restart the patient, bring all the core services back online, now that they have good instructions to work from.
But the long-term fixes are the really important part. They've committed to making their systems much smarter about catching bad files before they ever get deployed. They're adding kill switches so they can turn off one broken feature without nuking the whole platform. And the big one? They're re-architecting their services so they're not so tightly connected, meaning a bug in one place can't start a fire everywhere else.
And this slide really nails that change in philosophy. Their old way of thinking was fail-safe. Basically, if a component got a weird signal it didn't understand, it would just stop everything to prevent damage. The new way is fail-secure. Now, if some non-essential part breaks, the core system is designed to just ignore it and keep the traffic flowing. It walls off the problem instead of letting it take everything down.
In the end, this whole thing was a massive wake-up call. It showed us just how fragile our internet can be when we rely so heavily on just a handful of these gigantic, hyperscaled companies to run the whole show. It's a systemic risk that affects every single one of us.
And that really leaves us with this big final question to think about. There's no doubt that these huge, centralized platforms are incredibly powerful and convenient. But as we keep putting more of our digital eggs into fewer and fewer baskets, are we actually building a stronger internet? Or are we just building a much taller and much more fragile